Hello, I've been working on this, a rare Siemens 429 stereo, which is based on a Grundig V2000 2x8 video recorder. It's a rare model in both the Grundig and especially this Siemens rebranded version. Now, I've made a little bit of progress with it, but I'm going to have to get seriously stuck into the service manuals to make some sense of why it's not working now. The manuals are all in German. I know a little bit of German, but it's heavy going. I've been using translators to try to make some sense of it. Okay, well, we'll just have to make do. I don't think they ever made any English service manuals for this machine. Oh, I wonder what's in this. Yeah. Well, it's well packaged. It's the service manual to the Video 2x8 Mono 2080. Now, this machine is a 2080A, which is stereo, but the differences are all going to be fairly small. It's only going to be around the audio section, which is completely different. So, for the vast majority of what we need to do, this is a great help. And it's all in glorious English, which, especially when it comes to these larger parts here, where it describes the machine operation, it's really much better than trying to translate from another language. And here we are. It's got some handwritten voltages in there as well for the supply voltages. Well, we're going to go straight to that because it's the first thing I'm going to be checking is the supply voltages from the power supply. I know it's at least partly alive. So we're going to have a look at that, and then if they're okay, then we need to be thinking about, well, I'd like to know why the clock is doing weird things. So we'll examine that. It could be a problem with a reset, or it could be that there's a microprocessor failure, or that it's lost its firmware effectively. So we really need to go digging into all that. So I want to say a huge thank you to Aidan of Sticky Tape and Rust. Have a look at his channel, I'll link it below. He does restorations and repairs of old TVs from around about the 50s and 70s, UK ones, and he also does sort of TV idents, continuities and stuff like that on his channel. So do subscribe to him. Huge thank you to him. Let's get stuck into this machine. Well, I was just settling down to go nicely through the schematics and compare to the voltages that we're getting from the power supply, and I thought, that's going to be a lovely job, that. And the wheels fell off in short order because it turns out that the motherboard for the stereo version is completely different to the mono version. Not just subtly. So, for example, here we have the tuner, and right next to the tuner on the mono version, we have the power supply output pins along here. But on this version, the stereo version, for which I have the German manuals, the pins for the power supply are set over here, away from the tuner ZF. So it's an utterly different power supply and motherboard. That's not to say this won't be useful, because if we get stuck into problems with the clock, it's very likely to be correct. But the motherboard is different and the power supply is different, so I'm going to have to go back to the German manuals at least for a while. And if you didn't see this at the YouTube short I did about this machine the other day, let me show you what happens when we power it up. So it's switched on at the isolation supply, switch it on, and the whole display sometimes lights up. And then you switch it off and on, and sometimes segments of the display will light up, or none of it. So that feels a bit like a possible problem with a reset line, but I have been told that it could be a problem with corrupted firmware, so that could be a right nuisance. But okay, as best we can, let's check the supply voltages are correct along here. What we can glean from the English manual is that A is always during record, D voltages are always present, E is switched on, F is a function, well, we won't get that far, and W is during playback, and we won't get that far either. So we're going to be looking at the switched on and always on, so the D's and E's. Right, good. So this is a D. It's the 18 volt line. So we're going to switch machine on and see if we have 18 volts there. Okay, we do. The next voltage is on pin 8, and it should be a 12 volt. And that is a D, so that should be available to us. Yes. And the next one is pin 9, but that's a W, I think. I can just about read it. Is it a W or is it an M? I'm not seeing any M's on there. Don't know what to make of that. No, I don't know what to make of that. So I'm not sure whether we'll see a voltage on pin 9 or not, because there seems to be a difference between the English and German ones. Yeah, so I don't know if we'll get a voltage on pin 9 or not, because I'd have to wade through the German manual to find that out. But yes, we do have 12 volts on there, slightly more. Okay, our next voltage of interest, because we then have a couple of grounds, is 33 volts. And the 33 volt should be a D, so we should have that. It's a little low at 31.4, but that's probably okay. Our next is -7 at pin 13, and that's totally wrong. So we need to take a note of the fact we do not have the -7 voltage. Next is pin 14, which should be it's a D, so we should be able to see it. There should be 12 volts on 14 and 15 actually. So 14, yes, and 15. Yes, okay. Then we've got HZG. I don't know what that is. High ZF2. I just don't know what that means. On pin 16, we'll measure it. It's 10 volts, but I don't know if that's right or not. Then at 17, we've got an F, which again, that should be during function, so we won't get that one. We'll check that we don't have it, but we won't have it because there are no functions operable. Okay, so there's nothing much on there, as we would expect. And then it says A12 and W12. Again, I don't know what they are, but nothing there on either of those. 20 is switch on signal. I think that'll be this power button here. So let's try it. So as I press the button, nothing changes. 22 is 5E. So I think that will be always on. No, it'll be on when we're switched on. There we go. Little high at 5.6 volts. Yeah, definitely a little high. The next one is function. 5 volt in function, so that will not be on because we do not have a function running. 25 should, I think maybe that operates with the on-off switch. We'll have a look. 25, so it's low, switch it on, and it goes high very slowly. Very creepy uppy voltage. And that should go up to 5 volts. That's not feeling right at all. Okay, pin 25, we don't like that. Should go to up to 5 volts, and we're going up to about 0.5. So there's a problem with that, and that could be our reset issue that we're having. Well, we're having problems with the clock and what have you. So that's a very interesting voltage. That's telling us a lot. Okay, 26 and 27 are plus or minus 150 volts. So I'm going to be suitably careful with that. So 26. How many? Minus 150? No, nothing like it. And 27 should be plus 150. That's closer. So 26 should be minus 150, and it's nothing like it. And 27 should be plus 150, and it's a little low. Okay, so right there we have some anomalies in some voltages. And I'm particularly interested, I think, in the lack of that 5-volt signal rising to 5 volts on pin 25, which I think implies a possible reset issue. And the minus 150 volts is only minus 11, so that clearly won't work. And the minus 7 is only minus 1.7. So I think we need to get the power supply out, but at least now we're not just poking about in the dark. We know the sort of readings that we're not getting, and we can go and investigate those. Good, that is a good start. Okay, since we know what supplies are wrong, let's get the power supply out and look at the schematics, the German ones, and see if we can work out why some of those things are wrong. I spent some time trying to work out where the reset is coming from. So this signal here that's supposed to go up when it's on is, well, there's also a switch involved, but it's derived from the process control or Ablaufsteuerung board at the back here. And that derives its reset from the main microprocessor chip on that board, the TMS 7040, which in turn has a reset signal which is generated on the Ablaufsteuerung board. But before it goes anywhere, it's fed out of one of the connectors on it, out to the DTF and servo board, and then comes back inverted from that. Except this version doesn't have anything plugged into the socket which goes out to the DTF board. How unhelpful is it that different versions have got different connectors for different purposes? It's really difficult to follow the manual. The same manual covers a range of different machines which have got completely different baseboards, different power supplies, and different cables connected to the boards. So it's baffling how the reset is derived. I haven't been able to resolve that problem. So putting that aside for a minute, one thing we do definitely know is wrong is we don't have the minus 150 volts line. Now, I'm sure that's not causing all our problems, but we still do need the minus 150 volt line. And without that, you don't get the minus 7 volt line. And because we're not getting minus 7 either, that pretty much eliminates the possibility of us having blown the fusible resistor out to the minus 150. So it's something else wrong with this part of the circuit. But the plus 150 is okay. So we need to be looking at these components here. A big problem being that we can't do any measurement checks on the power supply because we don't have a board which will allow us to work on it, one of the riser boards. So we're a little bit stuck there. We're going to have to just do cold measurements. And of course, fixing the 150 volt line is not going to solve anything, but it's something we can work on. So let's do that for a minute and see. That's not going to fix the reset, I'm sure, but we've got to have a look at something that's obviously not working, something we can look at in isolation. So here's our power supply board. We'll take that out and we'll look at why the minus 150 and minus 7 volt lines are missing, but not the plus 150. It's the second to last pin. So the last pin is plus 150 and the second to last is minus 150. So let's follow that back. You can see by a certain amount of dust on there that it's a high voltage signal. They are derived from a transformer, which may or may not be that one. And there are two rectifiers, 442 and 443. We know 442 works, maybe 443 doesn't. So we'll check that. Well, I may have found something. It seems that the transformer has got a center point here. This is the output side, the high voltage side with the thinner wires. Okay, 1.5 ohms is the winding. But on the other side, it's kilo ohms. And I'll bet that the side that's working, let's put it into sounder mode. The side that's working, this top one, will be the side that goes to the diode that's good. Yeah. And the side that's not working will be the side that goes to the diode, well, that's not producing anything over here. There we go. The reason we have no minus 150 and no minus 7 volts is because the minus output voltage winding on this transformer has gone open circuit, and that may not be repairable. If we're lucky, it's just gone open circuit where it's got a binding post here, and I've had that on a Grundig transformer on a piece of audio equipment from 1960 something, a very rare tape recorder format called DC International, which I fixed quite a few years ago now, about 5 years ago I think I fixed that, and we had an open circuit transformer in there, and it was because the wire had separated at the binding post. So I think the only thing I can do is take this transformer out and have a look and see if there's any hope of repairing that transformer. There are so many possible things that could kill this video recorder, it's untrue. And we still have the problem with the reset well, I'm pretty sure we've got a reset problem. But until I can fix this power supply, there's no point worrying about anything else, because we've got to fix the power supply. Because that minus 150 volts will be used by the DTF, so it won't work without it. So I'm going to have to desolder this transformer, either with solder wick or my desolder pump. I've got an electric pump. It could be a bit awkward because there's heat sinks on the top, and that might foul it up, so I may have to move that as well. I'm hoping not. Get that out and see if we can find out why that winding is open circuit. Right, let's get started. Interestingly, something's written here. Something's been handwritten, and I think it says D425 BYW, something like that, 9.8100. So that's implying that somebody's changed a diode D425 at some point, wherever that is. Let's have a look. So there it is, that's D425. And presumably it's a BYW98. I don't know what that part is. Let's have a look at it on... Oh, look, you can see that's been soldered fairly neatly. Whoever's done that's done a good job. Albeit they've left the leads somewhat curled round. I tend to square them off when I'm inserting a component because I'm concerned that might put stress on the diode body. But even so, it's a fairly neat job. Where's that diode? Well, it's associated with this same circuits we're working on for the plus 33 volt line. So that's another winding on here. Okay, there's quite a lot of grot coming off this transformer, which isn't a good sign, is it? What is that? Oh, and you know what else I've seen rolling around in the bottom of the cabinet? Was this. And now I think I know what it belongs to. It belongs to this transformer. Oh, that's not good. That's going to mess up its its operation, isn't it? I mean, we can glue it back together. I guess we'll have to, because we will never get hold of a replacement transformer. Okay, so that's another thing we need to repair. I found this rolling around in the cabinet the other day and thought no more of it. I thought, well, I'll come back to that later. But now we know what it is. So this is the primary here, and we should have windings connected up here. But I think I may already have seen some damage. So let's look at that under the microscope and see if we can fix this transformer. This is very reminiscent of that Grundig transformer in the DC International player. So we need to see if there's any connection to anything for every pin, because I'm not terribly clear exactly what winding belongs where. It's not all that obvious, but here's the primary, we know that much, and that's okay. Then, okay, these two are good. That doesn't meter to there. Does it meter to anything else? Oh, yep, that meters to there. So we're just to this side, where this one we've already checked, this one we've already checked, so it's these two that, well, we can see that we've gone open circuit. We've lost both connections here to these pins. Okay, That doesn't look too hard to fix, does it? We can do that. I just need some very fine wire. Okay, I have some suitable wire. This is a little bit thinner than what's on there, but it will do. So I'm just going to have to solder straight onto it and hope that we can go straight through the enamel coating. It should just burn off. Yes, I think that's worked. Now solder that wire to its post. That looks good, but I can't really test it until I've done the next one. Okay, let's see if we now have a reading between those pins. If so, then I'll check all the others again before I refit it to the board. Looking at the transformer, it looks like it's intentionally built with a split there, but obviously not here. So I've got to think about what kind of glue to use. I want a glue that's got a very small dimension, because I don't want to push the two parts away from each other, but I need some strength. So what I think I'm going to do is hold it in place. I'll clean up the edge a little bit, hold it in place with super glue to give it the correct position then, and then on top of that apply epoxy resin for some mechanical strength. Well, no, I changed my mind. I went just with epoxy resin, and I've mounted it in this vice here, so hopefully that will set it into the correct position. Okay, so that's all in one piece now and is, I believe, electrically good. I will go around once more and make sure that every winding is connected. We can now refit this very carefully and check that we get the correct DC readings, and then that we get the correct voltages on the output of the supply. It's a bit fiddly getting it past the heatsink, but we'll find a way. Okay, I've reinstalled the transformer underneath this heatsink, and where before we were able to read the 150k resistor, which straddles some of the windings, we won't read the 150k resistor now, 120k resistor. Now we measure just ohms. So we can refit this and see if the 150 volt, minus 150 volt and minus 7 volt line reappear. Okay, we're ready for the great switch on. If I've got it right, we'll see minus 150 volts on the multimeter. Right, here you go, switch it on now. Minus 165 volts. So we fixed that. And let's check that we've also got the plus 150 volts. Yep, that's a bit generous actually. It was about 145 before. And we also need to check the minus 7 volt on pin 13. Minus 7, yeah, a bit generous as well. But that's fine. So we have made some progress. We've fixed the power supply. However, pin 25 is the one that was supposed to go up to 5 volts when you switch it on and was only going to half a volt. And I'd be very surprised if that's changed. So I switch it on in standby, switch it on there, and it's still only going up to half a volt. So that problem remains. So we still have something like a power and reset fault, but or some kind of switching fault. But at least we've got the high voltages in there now. Let me show you what's baffling here. The sequence control, or Ablaufsteuerung, is here on both the mono and stereo versions. But on the mono version, there's a cable here connecting this port to this board, the servo DTF board. But on the stereo version, there is no such cable. You know, that's really strange. But nonetheless, it's the same board as far as I can tell. And we've got ground on pin 1, and pins 2 and 3 are negative and positive going reset signals, which should pulse when I switch this on. And we can look at that on this, possibly do it with a multimeter. If that doesn't work, I'll use an oscilloscope, and we'll see if we get reset in. So it should go back high. It should go momentarily low and then high on pin 2. If that's sitting at some strange voltage, then that's potentially our problem. So that's pin 2 here. It's not the best contact in the world. That's a bit of an issue. It's a bit grubby. Hopefully I'll make contact with that. So I'm going to power it up and then switch it on and see if we get any kind of sensible reading on the multimeter. So power up and it's low, switch it on and it's hanging around a volt or so. Little surprise then that the clock's not resetting. So we have a power on reset fault on the Ablaufsteuerung board. Oh, okay, that's progress. Can we trace that back? So I believe that board is the same on both versions, so we can fault find that. The trouble we had earlier, we had this last week, was it's a bit awkward to get this board out. There's a lot of connectors to undo, but I may have to. But also, by the way, there's supposed to be a cardboard insulator between that board and the deck, and it's missing, which is just a bit of a safety hazard, I think. There's no actual prospect of that board hitting the chassis, unlike on the Grundig 2x4 Super, where there's a very real prospect of it hitting the chassis. So let's see if we can trace the power on reset signal back to where it's generated on this board. Okay, having found the correct version of this board, because there are two versions, we have the one that doesn't have a power on reset IC. We're looking at the reset pin, which is pin 14 on this IC, and I believe it's reset bar, so it should be reset low. So let's see what we get. Okay, so we're on pin 4 now of IC 1565, which should be the output of this exclusive OR gate. The other side, one of the inputs is ground, the other input is what I believe is the power and reset circuit. So let's see if we see any activity on pin 4 when I switch it on, initially in standby and then with the on button. So it's in standby, nothing. Switching it on, nothing. I mean, really, nothing at all. I'm just going to do a quick check of supply voltage, because I'm starting to not believe anything. I think here we should have some voltage. I've got 12 volts on that pin. That's a 33 volts. Yeah, the machine has got life in it. Let's check that IC has 5 volts on pin 14, because it all seems a little bit dead. So that's worth doing, isn't it? And see if it's got 5 volts. Because if it hasn't, then that's why it's not doing anything. So switch on. And it's got strange voltage going on there. And I switch. Yeah, dear. Right, there we go. No 5 volts on that pin. We don't have... There's our problem. We don't have 5 volts on the chip that does the reset. Presumably you don't have 5 volts in other places on the board as well. So we've got a problem with this board does not have a proper 5 volts. Let's try and find out where that's generated and why it's not getting there. So stepping back a little bit, we did have 5 volts from the power supply when we first checked it a while ago, but let's check that that's still true. Okay, pin 22 should be 5 volts. And it is. A little generous, but that's fine. So we have 5 volts from the power supply, but we're not getting 5 volts on the board at the back. So we need to chase through where that 5 volts is supposed to come from. So on this rear panel, Ablaufsteuerung, we have 5 volts coming in on this connector here. So I should be able to meter it, but I mustn't touch this. That could be quite bad. So we do have 5 volts getting to this connector. So we need to find out if that's the same 5 volts as should be on this IC that does the reset and no doubt lots of other places. We could have a problem with this connector, or there could be a problem on the board. Trouble is now access. Gets really hard. I can't really get to very much of the board. So I'm going to have to look at the schematics to try to work out how the 5 volts goes from here to the IC. So it's plus 5 volts E on pin 14. We've seen that already. And we're looking at plus 5 volt E. So that implies either the board's broken or we're not making contact here. Right, I see that 5 volts should come in on this board and then come out on some other connectors here. And I'm not seeing continuity there between the back of this socket and where it should come out on the next connectors. So I am severely suspecting this connector is not making contact. So I'm going to clean up both the connector and the board and try to prove that this 4th pin along here, which is 5 volt into the board, then appears here, which is 5 volt out of the board. Right, let's do a continuity check between that 4th pin, which is 5 volt into the board, and this 3rd pad here, which is 5 volt out. Okay, I'm now seeing that, and I wasn't earlier. Right, I'm going to go straight to the on position with this. Let's see if we get 5 volts on pin 14 of that NOR gate. We do now. Okay, well the clock's come back. That's not particularly successful, but the clock's come back. So we're still not resetting or anything, but you know, at least we have 5 volts now. Does that work consistently? Let's just try inserting a tape, because I had my notes that said it would take a tape at one time. No, that's too much to ask. Okay. But we've made some progress. So go back to pin 4, 1, 2, 3, 4, which is the, I believe, power and reset output from that IC. Okay, so I'm going to do a single sweep now of what happens when I press the on button. And that's the power and reset, if it is, on pin 4. And I don't know, I would have expected to see a drop down. I'm not sure if it's power and reset or reset bar, but that just doesn't seem right. Let's change the scale and single sweep it again. And we should see 10 millisecond pulse, I believe. And we're not, are we? We're just seeing it go up and that's it. So I still think we have a power and reset problem. Okay, we'll stop there for this week. We've done a lot of good work in this. We've repaired lots of faults in it. It's just surprising, perhaps, that we've not made any progress. As far as the outside is concerned, it's still doing exactly the same as it was when we started. Can you believe that? Do you think we have a bad power on reset? I still suspect that. Perhaps if you can make some sense of the schematics, they're a little bit random. There's lots of wires going off to different places, and it's quite hard to follow where things are supposed to go, and the schematics somehow don't even seem to tally up with the actual machine. So it's pretty heavy going. I suspect we do still have a power and reset problem, but let me know your thoughts on that. Right, to answer the silly question I posed last week, what happens with a basic 2-head VHS machine like a 3V32 or similar if you install the heads back to front and try to play a tape? And by a small majority, you guys did vote for the correct answer, which is you get a good black and white picture, which is possibly not what you'd expect to happen. Okay, I'll do plenty more content on audio and video technology in the near future. Bye for now. Oh, this machine is so frustrating. Still no progress at all, and now the clock's not doing anything either. You know, next week I might possibly work on something else and have a think about this one.